So, good morning everybody. This is Shailendra Negi, KVONGC, and today we're just going to deal the chapter quadratic equation. Quadratic equation is an equation which is of the form ax square plus bx plus c is equal to 0, and the important thing is that a should not be equal to 0. If a becomes 0, then this whole term is going to be 0. So the equation will be bx plus c, and it will become a linear equation, right? Quadratic equation is a equation which is having degree 2. Obviously the highest power should be 2, but if this one becomes 0, then this whole term will be reduced to 0. Bx plus c will be equal to 0. Then that's a linear equation. This is important condition for that ax square plus bx plus c is equal to 0, but a should not be equal to 0. Now coming on to the second thing, the standard form of this quadratic equation is x square plus bx plus c is equal to 0. So there are going to be two values of x, and these values which find out the values of x, these are known as the roots of this equation, right? And these roots can be denoted by alpha and beta when we are just using the formula and all those things. So alpha and beta can be used as the roots of these equations. Now some examples of quadratic equations. This is an example of quadratic equation: 2x square plus 5x plus 3. Obviously the highest power is 2, the degree is 2, so this is going to be the quadratic equation. A is equal to 2, b is equal to 5, and c is equal to 3. Now the second one, x square minus 3x is equal to 0. Highest power is 2. Here the value of a is 1, value of b is minus 3, and value of c is not present over here, so it is going to be equal to 0, right? But this is a quadratic equation because the highest power is 2. Now coming on to the third one, 5x minus 3 is equal to 0. Ax square plus bx plus c, on comparing with the standard form, we come to know that the first term is missing, ax square is missing. So this cannot be termed as a quadratic equation because the highest power is not 2. X square is missing in it, right? So some of the examples we're taking, the equations are there which do not look like the quadratic equation. We can see the first one that says x square is equal to 3x minus 1. In this we see that it is not arranged in a proper form, that is ax square plus bx plus c is equal to 0, but we can move all the terms to one side and it will become like this: x square minus 3x plus 1. Now it is the standard form. Now the second example we're taking, see this one. Now this is the thing, we just open the bracket, solve it, and it becomes this one, 2w square minus, so it is a form of quadratic equation. Now the third one, we come to this one, see this one. So we're not seeing x square, y square, z square, anything of that sort. The power 2 is not seen here, but on multiplying this, it will become z square minus z, and this will come here, so it will become this one, z square minus z minus 3 is equal to 0. So it is a form of quadratic equation. And the see this one, the last one, 5 plus 1 upon x minus 1 upon x square. X square is there, but it is in the denominator. So if we can bring it to the numerator, we just multiply it by x square, and the equation becomes like this: 5 square plus x minus 1 is equal to 0. So if any sort of this equation is given, we can categorize it whether it is a quadratic equation or not by solving it. We have to solve this and find out whether it is highest power or degree is 2 or not. If its degree is 2, obviously it is a quadratic equation, otherwise it is not a quadratic equation.